certainly have seen his work longer than that, but I had the opportunity to meet him about 15 years ago. Ivo Desmet is one of the leading researchers in the area of cryptography in the U.S. He was one of the co-founders of, I think it was the third academic center in the United States involved in information security research. He has been involved in starting programs in education at a number of other universities around the world, has an international reputation for his work in security, and is currently associated with two positions, one at the University College in London and the other at the RCIS in Japan. He was recently named as one of, I think, only 6.
No, more.
Is it more than that?
I think there are around 20 now.
Around 20, 6 recent ones.
Yes.
Of the
International Association for Cryptologic Research.
Right, thank you. My memory of the acronym isn't so good, but it's a distinct honor to be named as a fellow of that group, and it's a distinct honor for us to welcome today Dr. Ivo Desmet.
Thank you. So what I'm going to talk about today is 60 years of scientific research in cryptology, and basically it's going to be more a reflection. I'm not going to do a survey of what has happened, but I think that it's going to be a time where I want to look forward to the future. And so what I will do is I will start very, very, very briefly from the first years until today. And the very is important there. And after having done that, then I will say what is actually cryptography. And the reason why I'm putting as a second issue instead of starting with that is that you will see that from the research which has been done over the last 60 years that the definition of cryptography has changed. And then the next question is, do we really need cryptography? Or on the other end, are we basically neo-Luddites who basically say that technology is really bad and we need to protect ourselves against it? And then I'm going to focus on crypto, in particular the research aspects. I'm going to start with talking about what are the strengths of our modern research, and then I want the balance stock. So I'm not only going to say good things, I'm also going to say not so good things. And so I'm going to look at what are the shortcomings of our modern research. And then I think I'm looking forward to the future with saying, what should we actually study in the future, and starting today, and then conclude. So this is very brief, as I said. The paper by Shannon appeared in 1949, although it actually predates the papers on information theory, but they were not declassified, and so therefore he wasn't allowed to publish them. And so that's why you see them out of sync. So you see the paper on the proof of the one-time path being secured after his work appeared on information theory, although in fact it was the work that he did on trying to prove that the one-time path was secure that led him to information theory. And that paper appeared in October 1949. So a little bit more than 60 years ago. So then you see that for a long time there was almost no scientific papers that appeared. And in 1974 there was the paper by Gilbert, McWilliams, and Sloan. Some of you still remember Gus Simmons when he was active. And what he had done is basically go around and speak to people in coding theory and speak to people in combinatorics, saying, how can you make sure that when you get a message that you can guarantee that it came from the sender and hadn't been modified? And Gilbert, McWilliams, and Sloan were the first to actually solve that problem. And that happened in 1974. It's a paper which is very rarely cited, but I think it's quite important, and that's why I put it in the very, very short list. 1976 was the invention in the unclassified area of Diffie-Hellman, New Directions in Cryptography. Obviously, this is a very important paper. In 1978, I put a paper there by Rivest, but there's no Shamir and Edelman. There's Edelman, but no Shamir and Edelman. You would expect basically the RSA paper there. But the RSA paper is basically a realization of what Diffie and Hellman were looking at. I think that the paper by Rivest, Edelman, and Dertusos is actually more important in particularly when you look at long-term research. And what they actually were trying to do is that you have encrypted data on the file server, and you don't trust this file server, but you want to use it, and you want to basically be doing computations with encrypted data. They did very little on it, but they just had this idea of that, which they called basically privacy homomorphism. And the problem was recently solved in 2009 by Gentry, and it was important enough to actually make the New York Times. So what we see is that the first paper was basically on the security of encryption, the second on the issue of authenticity, the third of working with encrypted data. So you start to see that if you're now wondering what the definition is of cryptography, it's not just the protection of privacy and the study of encryption. And other examples are Blakely and Shamir with the invention of secret sharing, Rabin, digital signatures and public key functions as intractable as factoring. And then there are other papers, which I'm not going to mention. From cryptanalytic viewpoint, the Lenstra-Lovaas paper is very important because today, if you look at many attacks that happen, they actually use that as a tool, and that's why I list it. And Goldwasser-Micali, I list that because I view that paper as basically the real start for the research on proven security, although you could say that Rabin was first, but there are differences, as we will see later. And there are many, many dots, and I said it has clearly, very brief, the survey of what has happened. Today what we have seen is a big explosion of papers. And so even trying to do that in a few minutes, you will never be able to do a good job. And so I know that that's not the goal of my talk. So the goal of my talk is to look forward and say, what should we look at in the research on cryptography? And so the first thing then is the question is, what's actually cryptography? And I gave an informal definition, and I put definition between quotes because you cannot give an informal definition, in 2000 by trying to actually give a formal definition for what cryptography is, and I failed. But at least the definition is different than what you will find in, for example, Denning's book that appeared in 1982 and other the textbooks, that I think it's important to see that it's not just the study of encryption. So the way I view it is that cryptography is the science and study of the abstract security aspects of data against a malicious adversary. And the abstract is important, although it's between parentheses, to basically distinguish it from the computer security. And so cryptographic systems I view as being, and they are being and have been developed to protect some of these security aspects of the data, and cryptanalysis then is a study of methods used to break such crypto schemes. As you see, there's nowhere, it doesn't mention, it says security aspects. And so that means that basically where we are today, what we may view as a security issue might be different than what we were looking at 60 years ago. And so that's clear from the slides before. Privacy was the main issue. Authenticity is considered today more important. There are also papers that combine privacy, authenticity, and reliability. Anonymity is a more new problem that has been looked at, in particularly by Sham, so that's one of the dots which is actually there. So, and there might be other goals that we haven't realized. So if you look, for example, at Gilbert, McWilliams, and Sloan, you could say, how the heck did it come that for so long there was never a formal study done about authentication until only 1974. Now, some people actually have looked at the issue of, has there been other studies? And the answer is yes. And they go back to the Dark Ages, the Middle Ages. But it wasn't in the mathematical sense of the word. But people had thought about it. And the fact that you have a document to which then you're going to basically attach a seal by basically putting some ribbon through it, making a hole or two holes actually, and then put a ribbon through, and then actually put a seal on top, implied that the seal, making a fake seal at that time was much more expensive than actually making a fake document. So people had thought about it before. It's not that they never looked at these things as some people claimed. So what I'm now going to look at is, do we really need crypto? And there are many, many different answers. And so from a scientific viewpoint, one could say that cryptography poses challenging questions worth studying from an abstract viewpoint. Okay? So it's basically, it says scientific viewpoint, it says from an abstract viewpoint, etc. The question then is, do we actually write that in our proposals to obtain funding? And the answer is no, we don't. So what we actually claim is we claim that our area is applied and applicable. And so I spoke about that with Safra Finani, who some of you know, and she basically, her reply was that if we say research in an area may be largely driven by practical need or intellectual curiosity, then it seems to me that recent research in modern cryptography has been primarily of the second type. I'm not saying that's bad, but we also have to take into account what it implies. So back to the question, is there a need for practical cryptography? So Andrew Lisko in 2003, I remember Andrew Lisko going around and saying, you know, this small company, he mentioned the name small company, just went bust because they were not thinking about information security. And he said, it's just a question of time before a large major corporation is going to go bust because they haven't taken information security into account. And then it didn't happen. And so basically, he started to change his mind. And so in 2003, he said that the really massive financial disasters of the last few years, I mean, now in 2010, you could say the same, but the companies have changed, okay? At that time, it was Enron, long-term capital management, WorldCom, owed nothing to inadequacy of information security systems. How can we explain this? So, is SSH not a great application of cryptography? Yeah, that's what we say. But where is the hard evidence? In particularly, how do we know this? So, even if you put intrusion detection in place, and then you say, okay, somebody tried to get into the system and SSH prevented that, how can you calculate the estimated economic saving? There is no figure of that. I mean, there are people who basically throw a figure and say, this virus costed the world so much money, but it's basically throwing a figure. And there is not hard evidence. And in particular, when you look something as cryptography and SSH, how much has it saved? And so, and I had some chat with Andrew Lisko recently, who said that if cryptography wouldn't have been there, then if you look even at SSL, people would have found other ways to make sure that the transactions are, e-commerce transactions are not too bad, that the security of them wouldn't be too bad. So and then evidently there is answer 2 from Gene Spafford, who stated using encryption on the internet is the equivalent of arranging an armored car to deliver credit card information from someone living in a cardboard box to someone living on a park bench. Many people have actually not understood that statement. The statement says that basically, if you focus on communication security, but you don't have on both sides, that where you have this the cardboard box and the park bench, you have insecure computers. Now, what is it good for to have all the security on the communication aspect? So, and I think that he's right. So then the question is, there absolutely no positive reply to the question, what's cryptography good for? And so I'm going to look to a statement that I made in 2006. And based on that, I'm going to try to answer the question. So I think that research may predict potentially new frauds, and it may propose solutions against these. So what I think is that if you look in the area, researchers are ahead. The hackers, they actually usually catch up with scientists. However, not immediately. It makes them several years, actually. So business avoids really to implement security as long as economically justifiable, even sometimes longer. And they try to avoid taking the responsibility.